Hi, in this talk, we present DSAG, a scalable deep framework for action-conditioned multi-actor full-body motion synthesis. Synthesizing diverse human-like action avatars in a controllable manner has significant applications in robotics, interactive animation and human-device interaction. DSAG can generate a large set of human actions with diverse body motion dynamics. Moreover, DSAG scales to multiple datasets with varying frame rate, categories, joint and locomotion. Given an action label, DSAG generates novel and diverse, full-skeleton human action sequences. To generate natural-looking action sequences, we incorporate full-body pose sequences with detailed finger joints. We extract skeleton using expose. Incorporating finger joints allows us to distinguish actions with subtle hand motions. We also perform parameterized temporal smoothing for temporal coherence in motion sequences. The motion is decomposed into the local and global components. Furthermore, we decouple body and hand joints. Our approach utilizes novel components of MUGGLE, an architecture designed for large-scale action generation. We encode the hand and body components in a decoupled manner. Although finger joints are more in number than the rest of the body, it has less degrees of freedom than the rest of the body and is underrepresented in a monolithic skeleton representation. We introduce a novel spatiotemporal transformation block to handle highly diverse and low frame rate action sequences. The temporal component applies the convolution filter within a small temporal neighborhood to capture subtle and diverse temporal movements. The multi-head self-attention block preserves long-term global dependencies within the action sequence. Overall SD block captures both the local and global temporal dependencies. This allows DSAG to generate realistic action sequences containing rapid movements of hand or leg joints. Remaining encoding blocks separately model the global movements and the index sequence length representation. Similar to MUGGLE, we adopt an extension of VAE known as Gaussian mixture VAE. Vector sampled from the latent Gaussian mixture is transformed using the standard VAE reparameterization trick, which is conditioned on action class information. The latent representation is mapped via the decoders to the 6D representation of the local body and hand components. 3D joints is obtained using forward kinematics. Finally, the outputs of all of these 4 decoders are incorporated to get the generated action sequence. Through DSAG, we propose an unified method to synthesize actions from multiple datasets with varying properties. Notice the large difference in frame rates being captured. Qualitatively, we observe that generations by DSAG are superior in quality and dynamics against baselines. Moreover, we can generate multi-person action sequences. Thanks to our newly proposed SD block, DSAG learns to capture very high within-class diversity. In conclusion, DSAG enables multi-actor full-body motion synthesis at scale in a controllable manner. The inclusion of a novel SD block allows DSAG to model complex human motion with diverse and subtle joint movements. Thanks for your time.